don't know the specific formula which is going to end my subproof, right? Don't have that. So what I usually do here, right, so this is why it's easy for people using indirect proof to get lost, right, to not know, right? The vast majority of people who botch the use of conditional proof and indirect proof in their exams and their quizzes are people who really don't know where they're going with a subproof, and they don't know when to end a subproof. They don't know, right, when to get back to the main line and the line. And please, all of you, indent when you're doing a subproof, separate it from the main line. Helps you to know what you're doing, as Klenk stresses in the text, right? But with indirect proof, as I say, you don't know the specific formula which will allow you to end it. But you've got to know what you're doing. You've got to know what kind of formula you'll need, right, what you're looking for, which will allow you to end the subproof, to get away from the subproof back to the main line. What I do is write a little x down the bottom. X representing contradiction, right? It's going to be something in the form of Q and not Q, but I don't know what the Q is. I don't know what formula in particular I'm going to get. But this is just telling me what? The last line of my subproof will be a contradiction of some form. Well, will be a contradiction. Will be in the form of a contradiction. Will be some substitution instance of Q and not Q. What Q is, we have to determine. We're just going to, basically what you do now, what you usually do for indirect proof is top-down reasoning. Bust out all the formulas you can, apply all the rules you can to get all the formulas you can, and then, you know, a P and a not P, or an O and a not O, maybe one of those, or maybe even N and not N will appear. And it is legal, as Klenk stresses, or she tells you in the text. If you assume N and not N is a perfectly legal substitution instance of Q and not Q, right? So N and not N can be the end, can be what marks the conclusion of a indirect proof sum formula. That's fine. But then you still have to discharge the assumption. First rule of using these assumption is every assumption has to be discharged. The conclusion you're tasked with proving must be on the main line, cannot be on a subproof, right? But anyway, the general procedure, you don't really know exactly, you don't know what the Q is going to be in the Q and not Q. You don't know what formula you're going to get, both it and its contradiction. So you just basically do, apply the rules you can, the usual rules, the modus ponens, the modus tollens, the destructive syllogisms, and so on. Do what bust out what you can, and more often than not, usually for the task, the proofs you're asked to do, a contradiction will appear, right? You'll be able to get both a formula and its contradiction, right? Well, you'll be able to get both a formula and its negation. And you will conjoin them, you must conjoin them to have your last line of the subproof, and that will allow you to infer not P by indirect proof. Okay? But the big thing I'm stressing is, right, to know how to have mastery of conditional proof and indirect proof is really to know where you're going and when you will be ending the subproof. And there's a big difference in conditional proof and indirect proof with regard to knowing when you end the subproof. Conditional proof, you can write down the consequent of the conclusion right away. Indirect proof, you can't. Indirect proof, you just have to be on the lookout for a contradiction. When you get it, you're done. Okay, so we've got N, right? We've assumed N. We're trying to reduce N to absurdity, that is, derive a contradiction from N, which will allow it to infer the negation of N. Since N is absurd, because a contradiction derived from it, not N must be true. That's the thought. So basically now I've got these 4 formulas to play with to derive what I can from. Okay, so 5 in the subproof. Obviously, I can get O by modus ponens, 1 and 5. The justification for the assumption is assumption, A-S-S-P, right? Assumption, brackets, for indirect proof. Not putting this light on because the glare is too bad. The assumption for, didn't put it up here, but this assumption for your indirect proof, A is, again, assumption, A-S-S-P, brackets, for conditional proof, right? So how do you justify this step? You say it's an assumption, which is what it is. Now you do need to know the expanded definition of proof and of a justified step. Now we amend the proof, as you'll see from Klenk's text. A justified step is now a premise or an assumption. That's what you're bad at. A justified step is either a premise or an assumption or a step that follows from the previous steps according to the rules of inference. Okay? And a proof is a series of justified steps. So note the expanded if you're asked to define proof or you're asked to define justified step, you have to give the Unit 9 definition. That's the latest one, all right? And you might be asked that in the exam who's watching this video. Okay, so we've got the justification for 4 is assumption, conditional proof, right? Step 5, O, is I've done modus ponens on 1 and 4, right? 1 and 4. It's the antecedent of this, right? So I've got N and O. I can put N and O together. Let's do that. Conjoin them, right? Conj 4 and 5, right? Conj 4 and 5 gives me N and O. Why did I do that? That gives me the antecedent of the conditional that is premise 2. So 7, I will do P. I infer the consequent P from modus ponens 2 and 6. Modus ponens 2 and 6. Of course, P is the antecedent of another conditional. So step 8 is not O, right? 3 and 7 modus ponens. Modus ponens 3 and 7. Okay. Now look what, and we have it. Okay. Okay. We've deduced O, and we've deduced not. We have deduced not O. Okay. We have deduced a formula and its contradiction. That's not the end of the proof. I mean, you've done all the hard work, but you will lose points if you don't completely, perfectly, rigorously match the form of the rule in your application of the rule, right? So this little x has to take the form of a explicit contradiction. You have to put them together, right? So step 9 will be the last step in the subproof. Come here, egg jock. Okay, so step 9 is conj of 5 and 8 to get O and not O. And that's good. Right amount of space, right? That's going to be the last line of the subproof. All right. 9 is conj 5 and 8. Conj 5 and 8. Right. So what is that? That's take an 8. O and not O. Right. That is a formula that is in the form Q and not Q. So we have a subformula. You know, how have we correctly matched indirect proof? We assumed a P, looking for a not P, right? That's correct match of the form. If you infer P and derive a contradiction, you're entitled to infer a not P, right? So that's my P is N, my not P is not N. Good, we've got that part of the form right. And the form, as you see, the only other part of the form of the rule specified, right? These are going to be whatever formulas, but the form states that the sub formula ends, right, with a Q and not Q. If you get any Q and not Q, then you're entitled to infer, right? You fulfill that other condition, and you're entitled to infer the not P. Any Q and not Q, and that's what we have. O and not O is this is a formula in the form Q and not Q. O and not O is a substitution instance of Q and not Q. The sentential form Q and not Q. Particular formula, sentential form Q and not Q. It is a substitution instance. Okay? So, what did we do? 4 was our assumption, 9 was our last step, so indirect proof, 4 to 9, and we have it as so. Alright? So that's indirect proof. Yes, that's what I wanted to say. This is a obvious, clear, easy substitution instance of Q and not Q, but that's not the, you can have substitution instances of Q and not Q which are much more complex than this, as I said, I think in part 1, right? It might be, space. You know, the last line of a subproof. You can see that. You can pause it if you want to look at it, but you can have a subproof that might be right. A by conditional B, and now what would it be, right? Not brackets A by conditional P. Right? This is a perfectly fine Q and not Q. This is a perfectly fine substitution instance of Q and not Q. Can you sort of read that? Sorry, there's a big glare there, but this is anyway, it reads A by conditional B and not A by conditional B in brackets. Right? Sorry, you can't read. Right, trying to avoid that side of the screen. So if you look at the exercises at the back, they give you a whole bunch of practice, which you should really do. Make sure you can do them all at for both conditional proof and indirect proof. Yes. So first of all, for conditional proof, exercise 1 is important, right? It says, given the following conclusions, what would be our first assumption be if we were using CP, right? That's exercise 1, right? So it's always the antecedent of the formula. That's what your assumption is. It doesn't have it here, but even more important, I think, is, you know, you should write these down, putting each of these formulas at the bottom, right? Because they're going to be the conclusion of this subproof, and write down the antecedent at the top and the consequent of this formula. That's what this question doesn't ask you. The consequent of that formula at the bottom, right? Because that's the whole game for conditional proof. Okay. Indirect proof. Yes. Okay. Question 2. Which of the following would qualify as contradictions, so they could be the last step in a subproof of indirect proof? Make sure you get all them right. That's recognized. You know, the equivalent rephrasing this question is, which of these formulas is in the form Q and not Q, and which is not, right? Right. So A hook B and not B. No, that's not a contradiction. It's not a formula. It's a contradiction, right? A or the first one, right? Sorry. A or B and brackets not A or not B. Is that a contradiction? No, it is not. Whoa.